Okay, Shahar, thank you very much for joining us. I think you should be able to begin your presentation now.
All right, so hello everyone, thank you for joining. Our call today is going to take us about then and now. We're going to take an example from a piece of the puzzle. We're going to talk about supply chain automation, front-end in-house automation and partner automation, the digital ecosystem enablement, development in a hybrid environment, which means the legacy environment.
You should be able to begin your presentation now.
Okay. All right. So development in hybrid environment, legacy, new platform, shared environments, then industry alignment, unified information models, standard data models, unified process certification, commercial requirements, markup, settlement, and netting. The commercial requirements, which include markup, settlement, and netting, of course, are very important. But let's start with an example about a pizza. Consider yourself going into a pizza parlor and you look at the menu, you order a pizza fungi. The waiter takes your order, brings it to the kitchen. The kitchen looks at your order, thinks if they can make it, they check the supply. They find out they ran out of mushrooms for some reason. So the waiter goes back and tells you, sorry guys, we have no pizza fungi today. Would you like something else? And then you order, let's say, a pizza pepperoni. And luckily, when the waiter takes the order to the kitchen, they find out they do have sufficient salami, spicy salami. They make the pizza. The waiter takes it back to your table. You eat the pizza. You're happy. You ask for the bill. The waiter takes the bill back to the kitchen. The kitchen prepares the bill, sends it back. You pay, and you go home. Well, you didn't get the pizza you wanted, but at least you got something. What happened? Basically, the kitchen was out of mushroom. The supply chain didn't work well. Either they were late in delivery, or maybe whoever was supposed to deliver mushrooms did not deliver it on time. So your experience was not as you expected. Now consider an automated pizza parlor. You go in, you check the menu. It's online. It's on your tablet or something. If there was no mushroom, the pizza fungi would not be on the menu at all. It's automated. If there's missing mushroom, missing elements, the respective elements will simply not be in the menu. You place the order, you pay right there, and it goes automatically to the kitchen. The kitchen prepares the pizza, send it out. The only time you actually see a waiter is when he delivers the pizza from the kitchen to the table. And maybe even that is now being automated using a conveyor. Then you just eat your pizza and say goodbye and go. A much smoother process. And the important thing is that the whole supply chain is automated, so you will not be facing a situation when you're ordering something and it's not available. So what are we expecting actually? What do we expect? And it's good for pizza, and it's also good for basically any other kind of service. We look for services to be on demand, private, predictable, secure. We want to have connectivity and data anywhere at any time. Console Connect by PCW Global is a software-defined interconnection platform that makes connecting to cloud-based business-critical applications and business sites simple, predictable, and secure. So where did we start? We started years ago configuring routers with manual human liaison with partners, hundreds of hours of engineering time to just develop all that and configure all those routers. Commitment had to have long contractual terms because delivery would take anything between months to 3 months. So new connectivity for every new project required a long lead time and typically also like 12-month contracts, because it doesn't make sense to contract for anything less than 12 months if it takes just 3 months to deliver the service. What do we have today? Today we have no offline communication at all. Everything is done through some sort of a GUI, a graphical user interface. Just click a button, no code, it's done automatically, which allows us to have a flexible commercial model. No longer a 12-month contract. By now we can have a much shorter contract, like maybe 1 month, 1 week, 1 hour, maybe even just a few minutes. Single connection to cloud, enterprise, global network in minutes. So we're now able to bundle not only connectivity, but connectivity and cloud, connectivity and application, connectivity and cloud and application, maybe some IoT devices, all within minutes, within a click. So this is a nice GUI, but what sits behind that GUI? We need to consider supply chain automation. On one side, there is a customer. Customer is facing the front end through which they consume a package, which could be a complex package or a simple package. Behind that sits our backend, which we call Console Connect, which is our own platform, which is accountable to the customer, and it chains internal and external supply. So like that kitchen, the pizza parlor, we have our own internal supply, and as well as external supply, such as, for example, the fungi or the pepperoni. So we chain internal and external supplies, and we settle both with the customer on one side for whatever they have to pay us for the pizza they ordered or the service they ordered, and we also settle with our ecosystem partners, to which we have to pay for the elements of service which they deliver to us. Could be a cloud instance or maybe geographical extension to locations where we do not have our own footprint. The ecosystem partner on their side are accountable to us, to Console Connect, and then deliver the external supply, whatever the supply is. And then they settle with us, Console Connect, and possibly they also have additional suppliers on their side. So basically, we're building a digital ecosystem. We're enabling a digital ecosystem that on one side, on the left side, has the user communities, which could be carriers, SMEs, enterprises, IoT devices, industry verticals, mobile network operators. And on the other side, we have the supply partners, which could be public clouds, IoT platforms, industrial SaaS, private clouds, commercial SaaS, data centers. And some of those entities can actually be on both sides. We can both buy from a public cloud, but we can also sell to public cloud. We can both sell to carriers, but we can also buy from carriers, because sometimes the carriers have element of service that we do not carry ourselves, and we need to take their elements of service in order to complement our services. But when it comes to development in such an environment, it becomes a bit more complex. At PSW Global, we've adopted scaled agile framework development with weekly sprints. So every week there's a sprint, a cadence, which is typical. Typically, if you're talking about scaled agile, you would have either a weekly or a bi-weekly sprint in a cadence that goes through 4 quarters with four program increments a year. That allows us to develop our own internal digital applications and our internal development. And sometimes we also use external developers because some skills we lack ourselves, and we have to get them from outside. Keep in mind, we also need to handle our legacy platforms, because whatever automation platform we deliver still needs to interface with our existing legacy platforms, because those platforms are here and they're going to stay for years to come. It's not that easy to get rid of them. But the thing is, when you develop an automation in a supply chain, you also need to automate or integrate automation of your ecosystem partners. Those are the carriers which have their own development framework. It could be scaled agile, it could be on a weekly sprint basis with a weekly sprint cadence, but they could use other methods. They could use other cadences like 2 weeks or 4 weeks or even month or whatever. So the complexity is to get the delivery and the development synchronized between one organization that has its own methodology and other organizations which might have other methodologies. And during our development, which we've been doing for the past 2 years, we have faced some challenges there. I'm not saying they cannot be solved, but they certainly are challenges. And you need to take into account that different organizations have different approaches, different philosophies, different dependencies. Things might not be as simple as developing in your own organization, which I would not say isn't complex as it is. In order to be able to develop that, you need to be able to align as much as you can. And so both organizations on both sides of the development cycle are using as similar as possible processes. So we want to reach a situation where supply chain management is done through an automatic extraction of active services, bi-directional matching of records, undisputed billing statement, AI mismatch reconciliation in case of mismatch. So think of the life cycle of a service. It could be any service. It could be a pizza. It could be a telephone call. It could be a connectivity service. It could be a cloud instance. It could be a combination of multiple elements, such as connectivity and cloud service, and maybe an application running on that cloud instance. On one side, on the left side, we have the CPQ, configure, price, quote, where we run through an inquiry, the composition of the requirement, which breaks it down to internal elements which we can deliver ourselves and external elements which we should be sourcing externally. We have the external quote, which is where we have to receive a quote for external elements which we cannot deliver ourselves. And we have the internal quote, which are the elements which we have to deliver ourselves. And then after we have all the quotes from all the respective supply chain partners, we have to recompose that into a solution that can be sold to a customer. We have to mark up to make sure we make some margin on the service, that we're not losing money. And then we send the response to the customer. Quite complex, just for the simple thing of receiving an inquiry and responding with a price. Today, that takes a minimum of a week. In the future, that should take no more than 2-3 seconds, including the supply chain management. Now we go to the ordering. Customer is happy. They click order, or maybe they just click activate. Activate means they consent to the rules, to the price I've quoted, and they're willing to place an order, but they're willing to activate and pay. So we need to receive the order. We need to reserve internal resources. We need to place external order with our supply chain partners. And then if our supply chain partners accept the order on their side and our internal resources are available, only then can we respond back to the customer, we've accepted your order, because we still have the ability to say, sorry, no can do, order is declined. Once order is accepted, now we go through delivery, which means we need to receive external confirmation from external partners that they have been able to deliver their element. We need to deliver our internal elements. We need to orchestrate end-to-end internal elements and external elements. We need to update our repository to sign that those resources are as in service. And we need to manage that repository to make sure that it is not reused. And if anything happens, we need to make sure that things can be repaired. Then we have SOM, service operations and maintenance, which means we need to manage faults if there are any. We need to measure and report performance. We need to reinforce SLA in case of outages or degradation in quality. We need to offer service credits in such cases. And having all that done, we need to make sure that we settle and book the money. So we need to prepare a billing statement. We need to send an invoice. We might be receiving an invoice from our supply partners. If there are any disputes, we need to manage them and reconcile any differences which might be. Maybe we didn't measure exactly the same. Maybe we have some dispute about SLA. And eventually, if we need to settle, and in some cases, we also need to net. What does net mean? If we have reciprocal business, which means I buy something from you and you buy something from me, then instead of paying each other the full amount, we just net and only pay the difference. What would be the commercial impact? Automation of whole supply chain service lifecycle management means shorter time to deliver, to quote, deliver, and change. So we're now able to act much faster, much more rapidly. Shorter lead times lead to new service types. And that basically means new revenue streams out of our existing infrastructure. It also means reduced billing and operational dispute. And it also means automated settlement, which basically speeds up processes which could take weeks today. So we're seeing a development of a digital ecosystem where we need to accelerate the speed and volume of transactions by using interoperable APIs, unified information models and processes, and blockchain-based settlement. And we'll touch blockchain a bit in a second. APIs in the front end allows us to have machine to machine without having humans involved. Not even front ends, just machine to machine. Ecosystem alignment is very important. If using unified information models, that reduces the chance of us ordering something and that order being misunderstood by the other party. It's not enough to have an API. We also need to make sure that the systems on both sides of the API speak the same language. And when I say orange, you understand an orange, not an apple by mistake. And blockchain in the backend and settlement means the ability to make sure that settlements are done and are not disputable. And are once and for all. So now let's address interoperability. We all started a few years ago, I think about 20-something years ago, with the NNIs, network-to-network interface, where one network would connect with another network, and they will be able to extend services across that NNI. So a service starts with a customer of mine, goes through my network, through an NNI to a partner of mine, and that partner of mine takes it over to another location or maybe another cloud instance, which I don't have on my own network. All that was configured, and in many cases still is configured manually. Now we're talking about SDN. SDN means software-defined networking. That basically means instead of having a human configuring devices, that means those devices are now configured through software. It could be a program, it could be a script, but it's automated in a way. Things happen automatically. APIs allow us to take the humans out, and it allows a machine to speak directly with the machine, application program interface. So a video conferencing client can use an API in order to book a call and to activate a call without me having to reserve bandwidth. All that is done in the background. For that to happen, we need to have common modeling, meaning a unification and federation of commercial framework and modeling, which is both on the technical side, on the equipment side, on the operational side, and on the commercial side, and that eventually culminates in commercial settlement through blockchain. In order to develop that, and when I say standards here, I don't necessarily mean formal standards. They can also be de facto standards. They could be open source based standards. The important thing is to make sure that those standards or common ways of doing things ensure interoperability, which means an interoperable cross-industry ecosystem. We must make sure they're inclusive, bringing together ICT service providers, technology vendors, and industry associations. We need to make sure they're adopted by the industry. Adaptation of standards and certification. I think certification was already mentioned by Pascal earlier, because it is very important for me to know that if someone claims they can deliver something, or they can do something, that they can really do it, that they have been tested and proven to be able to deliver it. And ending, of course, with collaboration, the collaborative development, and that is done through industry associations of sorts. It could be formal standard bodies like ITU, or it could be other organizations or industry associations such as MOBI, GSMA, ETSI, MEF, TM Forum, and CBAN. CBAN is a relatively new entity that is handling primarily the commercial side of business with certain success and deliverables already in place. So that is basically the end of my presentation. If there are any questions, I will be very glad to answer. Thank you.
Great. Thank you very much for the presentation.